when starting any content, it's important to get some vocabulary under your belt so that when that vocabulary is used later in problems or in exercises that it's asking you to do, applications, etc., you are comfortable with what the meaning of that vocabulary is and can carry out the process or answer the question. So this video is going to talk a bit about some foundation vocabulary with angles, specifically starting with geometric angles and then building on towards trigonometric angles that will get us started into the foundations for trigonometry. So here, geometric angles have measured from 0 degrees to 180 degrees. So when you think about a geometry class, the widest span that you would have between the two rays with a common vertex are going to be will be a span of 180 degrees. If it opens up any wider than that, you actually look at the orientation on the page where it's the smallest measurement between the rays that you could get. So when we have geometric angles, it's just from 0 to 180 degrees. What we'll soon find is that in trigonometry, we define an angle a little bit differently, and so we're able to get a wider breadth of usage with the angles in trig. Now with the geometric angles, an angle whose measure is between 0 degrees and 90 degrees is called an acute angle. So sometimes people like that play on words that it's a cute little angle. Any angle whose measure is between 0 degrees and 90 degrees. So even if you have an 89.9 degree angle, it would be considered an acute angle. Now an angle whose measure is smack dab on 90 degrees is a right angle. And when we do the notation for a right angle, a lot of times we'll show the angle and we will have this kind of little mark at the angle showing that it's a right angle. An angle whose measure is between 90 degrees and 180 degrees is called an obtuse angle. So those angles then would be ones that if you were to put a corner of a page of paper at the vertex and line one of the rays of the angle with one side of that page of paper, the other ray would show. You would be able to see it. It wouldn't be covered up by the paper. If you did that same process with an acute angle, the paper would cover up the entire angle. Now an angle with a measure of straight on 180 degrees is called a straight angle. Another type of vocabulary that comes into play when working with angles that are defined geometrically is that if I have the sum of two geometric angles and that sum, that addition of those two measurements add exactly up to 90 degrees, those two angles are called complementary angles. And we will have some theorems further on in trig where it talks about here you have two complementary angles, or the trig function of complementary angles is such and such. So it's important to make sure that you review that concept. And then the two geometric angles that sum to 180 degrees are called supplementary angles. So it's important to be able to do that. Now play on like just a memory device. If you think about the first letter of the word complementary is C and the first letter of the word supplementary is S. Well, C comes earlier in the alphabet than S does, and 90 degrees is a smaller number for an angle measurement than 180 is. So you can kind of think earlier in the alphabet goes with the smaller degree, and later in the alphabet goes with the larger degree for the sum. Remember, sum means to add up, and specifically it's two geometric angles that we have that. Now, next up, we're going to look at some examples of the supplementary and complementary angles. So first, let's look at each of these three examples to just practice the idea of the complement and the supplement. So the first one, find the complement of a 67-degree angle. So remember with complement, that is the sum of the two angles adds up to 90 degrees. So if I have my complement of the 67-degree angle, the thing I'm looking for, plus that 67 degrees, that's going to add to 90 degrees. Now, we don't need to write out this equation each time. It's just to be able to help you visualize why it is what it is when we find this value. Now, I want to know the complement of this 67-degree angle. So to solve this equation, I'll just subtract 67 degrees from both sides. And I'll have that the complement of that 67-degree angle is equal to 23 degrees. So just taking the 90 degrees and subtracting the 67 degrees. Now notice I did not write that 67 degrees is equal to 23 degrees because that's not right, correct? It's the complement of the 67-degree angle that's equal to 23 degrees. So if I'm going to write this as a final result, I need to make sure that I specify that it's the complement of the 67-degree angle that is equal to the 23-degree angle. Next, the supplement of a 67-degree angle. Well, remember, the supplement is that the sum of the two is equal to 180 degrees. So we could write it out again, that we have the supplement of the 67-degree angle plus the 67-degree angle has to equal 180 degrees. Solving for the supplement of the 67-degree angle, we're going to subtract 67 degrees from both sides. And so we get that the supplement of the 67-degree angle is equal to 113 degrees. So, kind of quicker process would be if you want the complement of an angle, you take 90 degrees minus that angle, and if you want the supplement of an angle, you take 180 degrees minus that angle. Now let's look at part C. Part C says, find the complement of the supplement of a 102-degree angle. So if I kind of wrote this as nested parentheses, we want the complement of the supplement of the 102-degree angle. So when I have nested parentheses like this, I want to start from the inside and work out. So the first thing I need to do is think, well, what's the supplement of a 102-degree angle? So take your 180 degrees, subtract 102 degrees, and you'll get 78 degrees. Now find the complement of a 78-degree angle. So complement, the two angles add up to 90 degrees. So 90 degrees minus the 78 degrees is going to give me 12 degrees. So my complement of my supplement of a 102-degree angle is 12 degrees. Next, let's look at a trigonometric angle and standard position. And these are the angles that we will use for many of the types of problems throughout the trig class. So a trigonometric angle in standard position has its vertex at the origin and the initial side is along the positive x-axis. So when I start to draw these, I think about my x and y axis, and I have the vertex at the origin and its initial side along the positive x-axis. So that's the initial side of the angle. Now, unlike the geometry angles that had to be from 0 to 180 degrees, and we just kind of measured the span between the two rays that had the common vertex, in a trig angle is actually the rotation from the initial side to the terminal side that gives us the trig angle. And also, we will name our angles by what quadrant their terminal side lands in. And we'll talk about the angle being a positive angle if you go up and around off the initial side to hit that terminal side. We'll call it a negative angle if you go down and around to go from the initial side to the terminal side. So your arc is always from the initial side to the terminal side, and it depends on if you go up and around for positive angles or down and around for negative angles. Now let's just recall from algebra that when I have my coordinate plane and I have my x and my y axis, the quadrants are numbered with your first quadrant in your upper right hand corner, and you go counterclockwise when you name these quadrants. So my upper right hand quadrant is Q1, and a lot of times we use Roman numerals to name our quadrants. Then if I go, the upper left hand quadrant is Q2, then Q3, and then Q4. So now if I have an angle that's shown to me like this, so I have the vertex at the origin, the initial side along the positive x-axis, I have the terminal side in quadrant 2, so it's a quadrant 2 angle, and I show the arc from the initial side up and around to hit that terminal side. That is a positive angle. And a lot of times we use Greek letters to name these angles. So I'll call this angle alpha. Alpha is the first letter of the Greek alphabet, and I did a small case alpha. You will see us use small case Greek letters for angles quite often. Sometimes we'll even use capital Greek letters. So make sure that you also kind of just review the Greek letters as well. Now, that's going to be a positive angle. If I have another angle, and I have my vertex at the origin, my initial side along the positive x-axis, and let's say I still again have my terminal side of my angle in the second quadrant, but I show the rotation down and around, and I'll call that beta. Well, this angle is a negative angle. So here, my angle beta is a quadrant 2 angle. So I'll go Q2 angle. And it also is a negative angle. So I'll have a negative sign in front of the degree measurement if I wrote out what the actual degree was. And here alpha is a Q2 angle. And also alpha is a positive angle here. Now before I erase this and come back with some other examples of this concept, let's just recall a few things. Just gone a little bit into quadrant 1. Remember that the coordinate axes meet at a right angle. So from the x-axis, positive x-axis to the positive y-axis, that would be right at 90 degrees. So any angle that is going up in the arc from the initial side to the terminal side and lands in Q1, and I haven't gone all the way around to get there, these angles are all going to be somewhere between 0 and 90 degrees. Now, if I've just done this positive angle and it's hitting the terminal side that first rotation around, and I have a Q2 angle, I've gone past the 90 degrees, but I haven't hit the 180 yet. So these are all going to be angles that are between 90 degrees and 180 degrees. If I did this positive rotation just the first time around and I go into Q3, well, here's 90, here's 180. This would be an angle from the positive x-axis around to hit into the terminal side into the third quadrant that would be somewhere between 180 degrees and 270 degrees. So notice trig angles can have angle measurements that are well beyond my 0 to 180 degree span that geometric angles were limited to. And then if I go into the fourth quadrant, positive angle within that first span around, it's somewhere between 270 degrees and 360 degrees because a full rotation is 360 degrees. To get practiced a little bit in working with trig angles and standard position, let's just draw some angles that they've given us the degree measurement for. So the first one is draw the angle theta is equal to 225 degrees. So I'm going to start by drawing the XY axis. Remember, the trig angle in standard position has its vertex at the origin and its initial side along the positive x-axis. This angle doesn't have a minus sign in front of it, so it's a positive angle, so I need to go up and around. And I want to kind of count the degree measurements as I go from what I know in terms of the measures within our quadrants as we go. So up and around 225 degrees, I need to go more than 90 degrees. I need to go more than 180 degrees. But remember, if I go 90 plus 90 is 180, plus another 90 would be 270, so that's too much. So it's somewhere between 180 degrees and 270 degrees. And in fact, it's right in the middle between 180 degrees and 270 degrees. So this angle theta is my 225 degree angle. So I can call that theta here, or I can say it's 225 degrees. Now for alpha in part B, again we're going to graph our XY plane. My trig angle in standard position has a vertex at the origin, initial side along the positive x-axis, but because I have a negative sign in front of it, I have to go down and around. And then when you're going down and around, the down part is already the negative part. So then you're going to count your degree measurements kind of with your quadrant degree measurements as you go. So think about going down is already the negative part. So if I'm going down just to here, that's just 90 degrees. I need to keep going. But if I went all the way to there, that would be negative 180 degrees. And I just want to be at negative 135 degrees. So I'm going to go about there to get my angle alpha. Now for beta, in part C, my vertex is at the origin. My initial side is along the positive x-axis. It's negative, so I'll go down and around. And it's just negative 15 degrees. So definitely I haven't gone past that 90 degrees, and I'm not even close to the 90 degrees. So I'm just going down 15 degrees. So that's going to be my angle beta. So in part A, we drew our theta angle, and its terminal side landed in the third quadrant. So this is a third quadrant angle. In part B, my terminal side also landed in the third quadrant, so it's a third quadrant angle. And in part C, my angle's terminal side landed in the fourth quadrant, so that's a fourth quadrant angle. So we've got that part. Now also, if you were to look at superimposing this XY plane onto the one in part B, and we looked at what would happen if we went with the measurements of our problem part B and our problem part theta, because if you did the total of the rotation, so this is 225 degrees up and around, this is 135 degrees down and around, but if you think about just that rotation, that would total up to 360 degrees. So we actually get that if I superimpose this angle onto that one, their terminal sides would coincide. They would have exactly the same terminal side. So if I did for this our angle theta and our angle alpha for this particular problem, they would have exactly the same terminal side. And when two angles have the same terminal side, they are called coterminal angles. So when you have two angles that have this occur, then you have coterminal angles.